who is a professor of mathematics at Cal State Fullerton. He received his PhD from UC Berkeley in 2002 and has taught at Cal State Fullerton since that time. He served as department vice chair from 2011 to 2017. He's authored many books and articles focusing on pure mathematics and math education. Scott is the director of a National Science Foundation funded program, Graduate Readiness and Access in Mathematics, which he will talk about in his presentation. He has won several awards for excellence in teaching, such as the Distinguished National Teaching Award bestowed by the Mathematical Association of America, Henry L. Alder Award in recognition of distinguished teaching by a college or university mathematics professor, which is awarded to only 2 or 3 faculty per year across the nation. Scott enjoys traveling, listening to music, and climbing mountains, which he will share with you. He'll be climbing Mount Killy next year. We're all hoping, keeping our fingers crossed. So please welcome Professor Scott Annin.
Thank you very much. I hope that the microphone is reaching to the back of the room and that you can all hear me. Thank you, Janice, for that very nice introduction. I'm honored to be here today here at the Osher Lifelong Learning Institute to share a little bit of what I'm passionate about, what I've been doing here in my 18 years as a professor at Cal State Fullerton. It's been a wonderful ride, and it wouldn't have been so without the help of a lot of great people that I would like to recognize. The Department of Mathematics here at the university is a wonderful place to work. This is about as close as we could come to getting a group photo of all of us. We're a very large department, and we serve a huge number of students. But these guys have been very supportive of all of my endeavors, helping me to pursue my passions as a mathematician throughout my time at Cal State Fullerton. Really, for me, everything begins and ends with the students that come through my classrooms, and one of my favorite days of the year is here on campus when we get to recognize the students that are graduating. Years and years worth of pictures. I take lots of pictures, by the way. There's going to be a lot of pictures in this presentation. But this is a very special part of being a faculty member here on campus, is to see this day and to help the students to reach this milestone in their lives as well. There's lots of things that go on in between as the students are navigating their time on campus, and all of it is inspiring and wonderful for me. I feel privileged to be a part of it, taking students to conferences and seeing my research. I'm going to talk about some of my mathematical research projects today, seeing those students present their work at conferences, and seeing students that have just excelled in the classroom, graduating with honors, and so on. Just everyday moments like this that really add up through the course of a career. Lots more pictures of students doing all sorts of fun things, from sports to presentations to working in classroom activities together. It's a wonderful environment to work in here. That was my birthday a few years ago. It's outside my office, so I have some pictures of students doing that. A few years ago, we hosted the Southern California Conference for Undergraduate Research right here at Cal State Fullerton. It's the largest undergraduate research conference in the region, and I somehow ended up in the middle of it as a co-director of the conference, and I was very fortunate to have a number of our math majors step up and help with volunteering at the event. So they've got their SCUR t-shirts on, Southern California Conferences for Undergraduate Research. This is another picture. I always take pictures on the last day of the semester of the math students that have been in my classes. Hopefully all of the math on the board is correct. I'm sure you'll let me know if you see any mistakes. As we, down on the job? Yeah, that's laying down on the job right here. That's right. But anyway, what I would like to talk to you about today is sort of what are the best practices that we can take advantage of, or that I have tried to take advantage of through the years here at Cal State Fullerton, to give our students and our faculty and our staff the best educational experiences that we possibly can. personal top-rate educational experiences. And what I have discovered in my time here as a faculty member is that the best way to achieve that is really to give students as much of your time as you're willing and able to do, and provide them with resources to succeed. And I'm going to talk about some of those here today. If you are able to do those things, and if you're able to provide your students with this kind of a top-rate educational experience, you're likely to have those aha moments happen more often in mathematics. You know, math is, or actually not just in mathematics, in any field, but mathematics is very interesting. It's very much, for myself and for many of the students that I've talked to, it's an experience of like being in the dark in a room and you're groping around for the light switch and you can't find it, right? And you knock stuff over and you trip and then you get up again and you keep searching around, and then suddenly you reach that light switch and you flip it on, and suddenly everything is much more clear. It's much more simple to you what's going on. You go, aha, I get it now. And it can happen in the strangest of times and the strangest of moments. It may not happen in the middle of a big long study session. It may be that that stuff percolates in the back of your mind for a while, and then 3 hours later when you're driving down the 57 freeway, something hits you, you know. Well, hopefully nothing hits you that's other than in your mind, something hits you and you have this thought that turns out to be very, very illuminating. And so math is like that a lot, and particularly doing research is like that. And so these aha moments are very precious to us. We like to try to create as many of those for ourselves as we can. I'm going to start calling them mountaintop moments instead of aha moments, because I love to climb mountains. And when you're on top of a mountain, you see a view that you never saw before. It's like turning that light switch on and suddenly everything is much more clear. So I will sometimes refer to these moments as mountaintop moments. And I love trying to create mountaintop moments for the people around me, in particular the students here at Cal State Fullerton. These are 4 ways that I try to do that. First of all, I mentioned before, giving as much time as I can. There happens to be a song that I like. The title is Time is Love, so I put it in quotes. And the message is very simple. If you want to know what people care about, what people love to do, just look at how they spend their time, right? That's going to give you a pretty good indication. So I try my best, and many of the faculty that I have had the pleasure to work with here at the university have done a great job of giving much of themselves in terms of their time to their students. Also, I think support communities, I'll describe some of these in the math department in a moment. Having support communities for students is really essential to their success, certainly essential for those aha moments to happen. And so the more that we can involve our students in those kinds of things, the better. Soft edge skills, I'll explain what that means in a little while, but there's a lot more to a professor than just their knowledge and their technical skills that they have. There's the softer side of a person, which I think is an important thing to present to students, or to show to students in order to help them to open up a little bit. And finally, having good projects doesn't hurt. If you have projects that students are able to get engaged in and able to pursue and have some success with, that's going to lead to more of those mountaintop moments as well. So I'm going to talk about all 4 of these main points in my presentation today. So time is love. I mentioned that as much as you are able to give time to your students, the more you're likely to see them have aha moments. And so this could happen in a research lab right here, a professor with some students, or at a conference. Or it's great to see students receiving awards for the work that they've done. These are ways when we are present with our students for these experiences, I think it is very meaningful for them. Here's a number of examples of students presenting their work at conferences. This may be the result of an aha moment that they may have had that led to them going to a conference and having an opportunity to share their work with others and perhaps create more of those mountaintop moments for the other people that they have a chance to work with. It's also nice to spend time with students outside of the classroom. It's a chance for them to get to know you and to just have a little bit of fun. So the math club always plays the physics club in basketball every year. So this is an example of that going on. I was a faculty advisor for a racquetball club that we had on campus for a few years. But these kinds of things, I think, actually do help those aha moments, those mountaintop moments to happen, because you're not just coming to a university to sit in a class, in a lecture with a professor who you can't really, get to know or touch. Here, you're getting a lot more of a chance to get to see the personal side of the people that you're working with. Sometimes you just go out at a conference, there's opportunities to get together with your colleagues, your peers, your students, and interact. And again, bringing out the best that we can in the students by giving them some of our time. So time is love, and I definitely have used that as a motto in my career. I spend a lot of time here, and I love doing it. That's the thing about it, is it's not hard for me. It's not a tremendous amount of work. It's what I love to do. It makes it easy. Support communities are also very important. We have a number of examples I can give you in the math club, in the math department, such as the math club and the Smart Girls. These are groups of students in our department that have sort of formed a bit of a, it's a club, but they have leadership responsibilities, presidents, secretaries, vice presidents, and they organize activities both on and off campus. Some of them are very math-oriented, such as conferences, and others are just chances for the groups of folks to go out and support one another and sort of share what's going on in their lives as they pursue their degree here at Cal State Fullerton. We also have a problem-solving competition in the math department every year. It's called the William Lowell Putnam exam. This is not an easy test. This is a national exam that about 4,000 students take every year. And we've been fortunate at Cal State Fullerton to be able to field a pretty good number of students that have had an interest in this. Usually 20, 25 students will show up once a year to participate in this competition. There are 12 problems on this test, and the test takes all day long. It's an all-day exam on a Saturday in December. There's 12 problems. They're worth 10 points each, so your maximum score is 120 points if you got everything right. So the nationwide average on this exam is 1 or 2. 1 or 2 out of 120 points. It is an extremely challenging exam. You need a support community if you're going to tackle something like this. The problems are quite demanding. So we don't just show up to take the test in December. We have a whole seminar that we run throughout the year where we have the students come and they may be interested in taking this exam. And sometimes a faculty and sometimes a student might talk about some examples of problems or try to think about what kind of tricks there might be. It's very hard to prepare for a test like this because every year the problems are completely different. You can't really do a practice test and have much hope that it's going to look like the real test. But it's still a great support community, the fact that we not only take this exam, but the students come in and actually work together for quite a chunk of the year trying to prepare for this competition. Here's a picture from a few years ago. Dr. Suchava, by the way, I have to give him a lot of credit for this. He's been organizing our Putnam seminar for many years. And I step in from time to time and give some talks. I try to figure out the problems ahead of time. I can't figure them all out either by any means, not even close. But we've had some very good students that have taken this exam over the past several years, and it's always fun to recognize them as well. I've already talked a little bit about conferences, so I'll move on for now and talk about, of course, what leads to student-oriented conferences are research activities. And we have really had a great culture in the math department at Cal State Fullerton for supporting our students in doing research. Every summer, a lot of math students will attend what are called research experiences for undergraduates. These are programs across the country that will pay students to come do research and live on a campus somewhere for 6, 8, 10 weeks and do a project. And although we don't officially have an REU program here, a Research Experiences for Undergraduates program at Cal State Fullerton, we essentially do have that because within our college and within our department for the past many years, we have been able to financially support students who maybe they can't go away, they have to stay local because of whatever their family situation is or their living situation, but they still want to get involved in doing research. They still need a source of income. I've been very, very excited about how Cal State Fullerton's math department has been able to support these projects and these students for many summers now. And it's been great to see the results of what those students have done because they've then gone out to many of these conferences that are student-oriented. And really, we put a pretty good turnout in at some of these national meetings with students from Cal State Fullerton. It's exciting to see that. We have something called supplemental instruction, which is fairly new. This is a great support community where students are teaching students how to succeed in generally their lower division math courses. So that would be like calculus or pre-calculus, maybe working up a little bit higher level than that as well. But what you have is a student leader who comes in addition to the students attending a professor's lecture. They go to a sort of a workshop where other students mentor them on actually the problem solving, which is what they really need to learn how to do for the test, right? And so they get exposure to problems that they may not get in the regular lecture class. And they get to work with their peers, other classmates that have stepped up to do this supplemental instruction. So this has become a big thing, not just in the math department, but across our campus, to try to get students more engaged in both sides of the teaching and learning curve. We also have something called the Fullerton Math Circle. This is every weekend, or most weekends, high school kids from the local area come to our campus, and we have some of our undergraduate facilitators who give presentations for them. Kind of sort of the baby version of the Putnam exam. The questions aren't quite so hard in the Fullerton Math Circle, but they're more geared for middle school and high school kids who want to try their hand at problem solving. And the Math Circle is a great way to do that. And again, we involve our undergraduates in leading those teaching sessions on the weekend with the high school students that come in. So a lot of examples, but this is the one in the great big blue letters that I would like to talk about that Janice mentioned at the beginning. This is the National Science Foundation program, GRAM. It stands for Graduate Readiness and Access in Mathematics. This is a program I've been involved in pretty heavily for a number of years. First submitted this grant, I think it must have been 2012 or 2013. Wrote a program proposal to the National Science Foundation. Me and a colleague wanted to try to create an infrastructure within the math department to support students, particularly students who wanted to not just finish their bachelor's degree here at Cal State Fullerton, but who wanted to go on and pursue a graduate degree. And so graduate readiness and access in mathematics has been very close to my heart ever since then. It's got a lot of great elements. By the way, we applied for the funding in about 2012 or 2013. We didn't finally get this thing started until 2016. It takes a while to kind of get things rolling in, but it's a 4-year program. We're currently in the last year. We have our last cohort of students running through this program right now. And we're supporting underrepresented and disadvantaged math majors. Maybe they have suffered some financial challenges or other obstacles in their lives, or maybe they're just underrepresented in other ways, that they could use some extra confidence, some extra support to help them succeed in their, not only in their math classes here at Cal State Fullerton, but in their preparation for graduate school, which is hopefully where they're going to end up. Our program involves undergraduate research, much like those REU programs that I was describing a few minutes ago. But in addition to that, we have a lot of other things. We will take our students to conferences. We'll work on the communication and comprehension of math. This doesn't get as much emphasis in the education world as I think that it should. You know, it's actually possible to do undergraduate research without really understanding it exactly, what you're doing. Like, you can collect data and kind of like draw some pictures and so on, but until you can really communicate your ideas clearly and, you know, be able to sort of have meaningful exchanges that are easy to comprehend between yourself and someone else, you know, all that work really doesn't matter that much, right? You have to be able to communicate. And so we spend a lot of time asking our students that are in our program to practice communicating. Sometimes they're talking about their research that they're doing. Other times we're having them just solve problems that are kind of not quite like the Putnam problems, but problems that require some skill to explain carefully. And so that's something that we put a lot of emphasis into. We bring the family members of the students that are in our program, that we select for our program, we bring them to campus every year so that they can hear what's going on with Graham, what their students are doing, what the other members of the cohort of students are doing, and just a chance to kind of build a community. This is much more than just some students in an isolated fashion just doing research. This is a whole community of people that are supporting one another and doing much more than just research. They're interacting in a variety of different ways. We're helping our students with graduate school applications and decisions. We already have several of our Graham alumni in graduate programs, mainly in the Southern California area. Some of our students have actually decided to first do a master's degree here at Cal State Fullerton, and then they have plans to transfer to a PhD program later on. We don't have a PhD program in mathematics here at our campus, but we do have a master's program, which really serves as a nice bridge for our students to sort of prepare themselves a little bit more for the rigors of what a PhD program will entail. And so I hope that the Graham program has helped those students to make that step. We've also developed some courses for this grant project, some new courses in the Department of Mathematics. This is one that I'm especially proud of, Math 281. It's called Problem Solving Across Mathematical Concentrations. A lot of students come in to the department not really knowing what you can do with a math degree. You know, okay, you can teach, of course, right? That's one thing, but like, what else can you do? What kind of careers are there, and what do the problems look like in different branches of mathematics? What do they look like in statistics? What do they look like in applied mathematics versus pure mathematics? There's lots of different concentrations that a student could choose to focus in mathematics. And so in this course, we've helped not only the Graham Scholars, but even some students who didn't end up becoming fully supported in our National Science Foundation program. Even some of them, I think, came in and had a meaningful and valuable, enlightening experience by being a part of this class. So we have course development. We also have a seminar that the students who are in our project attend every semester as well. So there's a couple of courses there, but I really want to emphasize problem solving. This is something that does not get as much attention as I think it should in a lot of fields, and I think that it's true in mathematics as well. How to think about math and how to sort of put together a logical argument that really makes sense. This is something that takes practice and time to get good at, and our program is very focused on doing problem solving in conjunction with other things like research and communication and comprehension of mathematics. But problem solving is at the heart of what goes on in our project. There's lots of evidence that problem solving is extremely beneficial and important. For example, cognitive complexities beyond simple memorization of formulas. You guys never did that, did you? Memorizing formulas. I see my students with the flashcards all the time, just kind of remembering the formulas, but there's much more than just that really needs to happen for a student to master a subject and to have a very full comprehension of a particular topic. Problem solving is learned. You can actually get better at it if you practice. This is why we have this problem solving seminar. And this is why in our GRAM project, we have our students practice presenting problems that they have solved in advance and then have them communicate those ideas. You can get better at it with practice. The benefits of problem solving have been demonstrated. So, this is actually something that is worthwhile, that we spend time working on problem solving with our students rather than just telling them the formulas, even more than just doing undergraduate research. I know it looks great on a student's resume. They've gone to conferences and presented their work and maybe even been listed as an author on a paper. But I really feel that if a student has strong problem-solving skills, that is going to take them very far when they get into graduate school. That's what they're going to need to sort of succeed at sort of the PhD level in mathematics. So there's a lot of emphasis on problem solving. This is a kind of a complex slide. I won't spend very long on it. It just has a bunch of the aspects of GRAM that I just described for you on the left side, the problem solving, the research, the family support, and so on. And then what we're hoping on the right-hand side, maybe is the more interesting part of this diagram, what we want our students to do, not only in GRAM, but throughout the math department. But particularly for GRAM, we want our students to graduate. We want them to get into a master's or PhD program and actually stick with it and succeed in that program, right? This is what we're hoping that our program is going to create. None of our students have been around long enough for us to see the completion of that program yet. It'll be interesting another 4 or 5 years down the line how those students are doing. We, of course, are going to be following them, tracking them, interviewing them about their experiences for years to come. Their grades, of course, we're watching how they're doing in their classes. The GRE, that's the graduate record exam that you have to take to get into graduate school at a lot of schools. Problem-solving scores and publications of research. So this is just a nice diagram of some of the outcomes that we are hoping that our program produces. GRAM is situated in an absolutely perfect environment here at Cal State Fullerton. This is a campus that supports many other similar types of programs. MARC and HHMI are both programs that support scholar students in other fields that are closely aligned with math, but not quite math. We have the Math Circle I talked about before, supplemental instruction, a bunch of different things that GRAM is able to connect to. Many of our GRAM scholars are involved in the SoCal Alliance, which is a community of students from different Cal State campuses in the region. And LSAMP is another program that we have a lot of presence with here at Cal State Fullerton that supports students, again, not just in the math department, but also across the campus. So it's great that we could, I think one of the reasons we got funded for this program here, I think if we had sent the same proposal, exactly the same proposal, but at a different type of institution, we may not have had the same success with the funding that we did here. It's because of the nature of our campus, the supportive way that we are able to help underrepresented and disadvantaged students, the care that we've taken towards helping the education of those students. So GRAM has been great to me. I've really enjoyed it, and it's been wonderful to follow my students. But it does create a big workload. There's a lot of work to be done, and the question is, how do you cope with that? We have a lot of very hardworking faculty, and I think people find different ways to cope, kind of take a release from all of the hard work that they're doing. But I have found a way that works well for me. I would like to tell you what that is. So I kind of lead a double life. I do a couple of different things. So, of course, from September to May, this is primarily what I'm doing, working with students and spending time in the classroom. But in the summer, I totally change gears and I go out to the mountains and I love to hike. As Janice said, I love to climb mountains. I love to get outdoors and see beautiful things. And so from June to August, I actually somehow managed to get hired to be a hiking guide in the mountains in Colorado. I work at a YMCA of the Rockies. If you've never been there, it is a wonderful place to come, especially if you've got family members or younger kids that like to play games and just outdoor activities, anything you could think of. Horseback riding, fishing, camping, just games around the property, a lot of educational things as well to learn about the environment. My job is a hike master. I lead people on hikes into the wilderness. And this is an aerial view of the campus. And what is a hike master? Well, there's a picture of what we looked like. There's about 15 or 20 of us that get together every summer, and we take people out on treks into the wilderness. And that's kind of our day to day. It's kind of hard for me because I generally don't teach classes early in the mornings here at Cal State Fullerton. But when you go hiking, you have to get up very early in the morning. It's actually quite difficult to do that. Also, you'll notice that nobody in that picture is dressed anything like I am right now. And so it doesn't really work to, kind of lead this double life if you're not prepared for the way you're supposed to look when you're doing this part of your life. So I decided to bring in a little show and tell. This is kind of the stuff that I have to do when I go hiking. So I brought the big one out today just to show you guys some of the stuff that I've got. So I'm going to open this up, maybe, see what I've got here. Of course, you all know that it gets very sunny, so you really should wear a hat to protect yourself from the sun when you're outside. And then let's see, these are my snow pants. I think if I put them on right now, I'm going to mess up the microphones that are hanging out of me. So I'll leave that there for now. Make sure you take a rain jacket, because if it rains, you're going to get cold if the wind starts blowing and you're wet. And you should never wear a cotton t-shirt, but that's what I have right here. This is my YMCA of the Rockies shirt. So, I don't know, maybe I should take this off for a second. Sorry, this will be family friendly, but I do have to be careful. Oh, maybe I shouldn't take this off. I see that I have the microphone there. I'm going to leave this on. Otherwise, they're not going to be happy with me in the back. So, that's okay. You get the idea. This is how I would look normally in the summer with see the big elk on the front? It's pretty cool. What else do we have here? Well, it gets very cold, so you can trade this hat for this one. I was wearing this the other day. It was really cold where I was. I'll tell you where I was in a few minutes. So this is keep your head warm when you're out there. So you have all of that kind of stuff. Of course, there's lots of other things. You've got to have plenty of water. So, I'm still learning too. This is lifelong learning. I went hiking the other day, and it was so cold that this thing froze. I couldn't open my water bottle. So I was like, yeah, that was real smart. I had plenty of water to drink, but I couldn't drink it because it was frozen. So I learned a lesson about that. I have to be more careful next time. Here's your gloves. Winter gloves are very useful up high. I know it's crazy to be thinking about this because it's, 85 degrees outside right now? But you go up, every 1,000 feet you go up in elevation, the temperature drops 4 degrees. So, and then the wind is usually blowing stronger up high, so it very quickly gets a whole lot colder. Let me open this up just a little bit further. What else do I have here? So I've gotten into, so sometimes you'll hear people talking about mountaineering as opposed to just hiking. So mountaineering is, they generally, when they talk about mountaineering, they're referring to going actually up into the snow, like onto like glaciers or very steep ice or snow. So you wear these things are called crampons, and it gets a little tricky because they're actually pretty sharp. The idea is that they kind of dig into the snow a little bit. They're like this, so you just wear these on the bottom of your feet, and then they just stick right into the snow, and you can go up much easier than you think you would. It gets kind of complicated at the airport. But anyway, and then of course along with that, this is the thing that goes along with the crampons. This is the ice axe. So you just kind of stick this down, and the idea is if you fall on the snow and start sliding, you turn around, you get down on your stomach basically, and you stick this into the snow and hopefully stop. I haven't had to use this yet. I mean, it works as a nice hiking stick as well. Oh, if you're not into crampons, but you are going to be on a little bit of snow, you can take these. These are micro spikes, so these are a little easier. You just kind of slip them over the top of your boot, and then they do pretty good. If the snow isn't too icy, they can get some good traction on that. So that's another nice trick. This is part of a pole. You have to collapse your poles, of course, when you get on the airplanes as well. So the other half is in here somewhere. I always hike with, I guess the other half of that's in there somewhere. I always hike with poles. I don't know, I see people without poles all the time out there, and I don't know how they do it or how they keep their knees from going bad, but this is a great way to distribute the pressure and the weight that that you're putting on the ground as you hike. So highly recommend hiking poles. Some of the younger crowd don't like hiking poles. They think that you shouldn't have to use them, but I'm preserving my knees is what I'm doing. And of course, sometimes it gets a little technical. So if the rocks are pretty steep, or if you're worried about rocks falling down on you, you might have to put on the helmet here. If I snap it into place like that. So I'll talk about the classes of hikes here in a little while, so give you an idea. But in case you fall, or if somebody above you knocks a rock down, you've got your head protected anyway. So you'd be very wise to wear this if you get onto some pretty rugged terrain. So anyway, I just wanted to show and tell a little bit of my gear here. And then you have all the food. Exactly, you have to take a whole bunch of food, and of course I am eating that all day long every day on my hikes, much more than I normally would on an off day. So yeah, we enjoy taking people on hikes out into the national park. This is probably what you have a picture of in your mind. There's a hike master talking to some guests that are coming along, that's staying at the YMCA and coming on a hike with the hike master to learn about the environment. And it's not always just walking on a trail. Here's a good example. This is Andrews Glacier. This is actually a glacier that is still an actual glacier in Colorado, and we sled down that glacier to the lake at the bottom of the picture there and then hike out. It's a wonderful experience. It's actually a lot of fun. It's a lot easier than walking down. You just sit down and go, but you do have to be careful. A lot of times there's no trail at all. Trying to reach the top of that mountain right there, you can see it's nothing but a rocky slope all the way up. So we're pretty serious about our hiking. It's not just a walk in the park, so to speak. You can end up on terrain like this where you have to scramble a little bit and just kind of sit down and scoot. We take people out and they love to do it. It's so much fun to take people out to experience this. As you can imagine, there's a lot of training that hike masters have to have. CPR, wilderness first aid. I lead a leadership and safety lesson within the hike master training program. There's a lot of other sort of educational components involving things that you want to talk about with your guests so that they can learn about the environment. And so our hike masters take turns leading those sessions for the new hike masters when they're in training. So a little bit about leadership and safety. You can see some of the dangers here. This is an example. You see the water running underneath the snow here. That is very dangerous. If you're not kind of aware of where the water is and you might be standing on top of it, you could punch through and end up in the water. And of course, that would be extremely frigid. And it can be very hard to dry out from that. Here's another example. This is actually a hike I was on. I don't know why we went hiking this day. It was snowing on us on the way up. We turned around, I think, at some point. So it can be very cold. We also have a lot of wild animals out there. This is a black bear that's just sitting in a tree. Got to be careful about that. They're always interested in food that you might have. And the one that particularly I find scary is lightning storms. There's more lightning strikes in Colorado than anywhere else, and people do get struck by lightning, and it can be deadly, of course. So we have to start our hikes very early in the morning if we're going to go up high above the tree line, so that we can get back down into the safety of the trees. Being underneath the tree line is much safer because you're not the tallest object that would attract the lightning strikes. So anyway, the hike master has to be aware of all of these sorts of dangers and be able to safely take their guests out into the backcountry. Those are the elements, as we like to call them, that are kind of beyond everybody's control. The weather, the wildlife, it's difficult to control those things. A hike master is very much like a teacher in a lot of ways. I like to make these analogies between my life as a professor here at Cal State Fullerton and my summer work as a hike master. Teachers have lots of things that they have to deal with beyond their control as well. With regards to their classrooms, issues that come up with administration and students, and there's all sorts of things that happen. There's also, of course, the people that come along with you on your hikes. I've had a number of people, I've been so delighted, a number of people from Cal State Fullerton who I've met here have made the trek out to Colorado to go hiking with me. These are some of my students. I had 4 students come out to visit me. They were going to come for 3 days to go hiking. And so I was going to do an easy hike the first day and then work up to a little more moderate hike, and then the last day more of a challenge. So this was the first day. We get up here, and these 2 guys decided that they'd had enough. So that was the end of that. So I only had the other 2. These guys came along the second day, and of course we got rained on. So this is their high-tech rain gear here. A trash bag is great, by the way, for rain gear. It works just fine. It's not very elegant, but it works. So there's your rain gear. So these guys did a little bit better. I've also had some of my faculty colleagues come out. This guy right here, Verl Klassen, is a good friend of mine. He was a major reason I came to Cal State Fullerton. He was on the committee when I was applying for the job here, and he came out with his wife to visit me in Colorado one year, and I loved it. This is Dr. Glesser, Adam Glesser, who is also an algebraist like myself, and so we have day-to-day interactions here in the offices at Cal State Fullerton. But he and his family came out to visit me, and of course he has a whole wide range of people here, and that's the other thing, the children. I forgot to mention about the children on the hikes. This is always an adventure. They don't quite know what they're supposed to be doing, so we have to kind of coach them along a little bit. But anyway, it's just been great to have so many people come out. This is a friend of mine from Fullerton College, Marika Klassen. She's come out a number of times to hike with me. She did the right thing. When she came out to hike with me, she told me before we started hiking that she was afraid of heights. She was afraid of heights. So I was very careful to choose hikes for her to go on that she would be comfortable with and that she would have a good time. So we did. We had a great time. Unlike this guy right here, who didn't bother to tell me that he was afraid of heights, but he was afraid of heights. I didn't know it at the time. And he's in great shape otherwise, so I picked this really big trek to take him on. And so we end up going up to the top of some huge mountain. So over here, yeah, we climbed up to this thing over here. We're coming back down, and do you see where, it's a little dark. Can you see he's right there, crouched down on the rocks, scooting down the side of the hill to keep from falling? I mean, it is tricky terrain. This picture doesn't show very much of what he has to do. This only looks like about 10 or 15 feet. But actually, we had to go all the way down to that lake down there. This is about 1,500 vertical feet, and it took hours to get down. We got back to the trailhead after dark that night. That's the other thing that's in my backpack somewhere is a headlamp. Always hike with a headlamp in case you're out later than you expected to be. But anyway, yeah, so that was a bit of an adventure. So sometimes the people can be part of the challenge in terms of explaining what concerns they might have about the hiking. We actually have a whole prerequisite system. When people come out and go hiking with us, we ask them, well, what other hikes have you done, and which hike master did you go with? And we give them a lot of information about the hike they're going to go on, make sure they really want to do that hike, because the worst thing is when the people get signed up for a hike that they really don't feel comfortable with. It's kind of the analogy of the student in your math class who wants you to waive the prerequisites or whatever, says, no, I'm ready, throw some calculus at me, and then you realize maybe that's not the best place for them to start. So it just depends. Okay, so as I said, there's the elements, there's the people, and so getting back to my 4 steps of my outline here, I want to just talk for a minute about soft edge skills with respect to people, because this is a really good way to create mountaintop moments for students. And a good outdoor leader has, of course, these hard edge skills, planning, technical knowledge, making hard decisions, and dealing with crisis. This is very important. But I would argue that a teacher has to have those same skills. You have to plan your lessons. You have to know your stuff. You have to be able to, evaluate students, make tough decisions, and sometimes, hopefully not too often, but sometimes perhaps deal with a conflict or a crisis that may come up. All of these are things that a good teacher needs to be able to do. But a really good teacher, I think, needs to have, in addition to those hard edge skills, a bunch of soft edge skills as well. This is going to help the students feel comfortable. I think so many of our faculty here at Cal State Fullerton do a great job with this. Developing trust, communicating with sensitivity, being understanding of the challenges that our students have. It makes them feel that you care about them, and then they feel more comfortable working with you. Being able to inspire your group of people, right? If you're able to do those things on the right-hand side, then you're going to not be so much the obstacle that the student has to overcome in pursuing their degree, but rather you're part of helping the team effort to make it to the top of the mountain, to finish your degree, or whatever the analogy might be that's appropriate for that particular person, right? They have trust that you're going to take them safely through the hardest of terrain, right? This is a scramble up to the very top of the highest mountain in Rocky Mountain National Park, which is Long's Peak, and you have to use your hands to crawl up this. And to get a group of people to follow you up there, it takes more than hard-edged skills. It takes trust, sensitivity, care, and concern. And that's something that I try every day to give to the people that I'm working with.
Do they have ropes attached to them there?
There's no rope here. No, not on this. This is not a roped climb. This is just scrambling with your hands. We don't take people on climbs that require ropes. If it's so bad that we have to use a rope to get somebody up the side of a cliff or something, we're turning around. Yeah. At least with respect to the YMCA hiking program, that's really what we do. Now, if you're able to develop those soft edge skills and create this, comfort and ease that your students may have around you, it's possible that your students are going to be much more open towards you. They're going to feel that you're approachable. And I have been very lucky to have students do this. They actually bring a good project to me. Instead of me having to go find somebody to work with me on something, it was just interesting that I had a student. This is Jairo Aguayo. This was a few years ago. I look like a kid too. He came to my office one night and said, I noticed something really interesting I want to talk to you about. And I said, okay. And so maybe you've heard of these Fibonacci numbers. So just to make a little list of numbers here, we start with 1 and 1. And if you add those two numbers, you get 2. And if you take the last two numbers, 1 and 2, add them, you get 3. 2 plus 3 is 5, and so on, right? This is the Fibonacci sequence. So many people are familiar with it. But Jairo did something very interesting with this sequence. Instead of listing them in a single column like this, he decided to list them in 2 columns. So 1, 1, 2, 3, 5, 8, and so on like this. And if you just look in a particular column now, right, what you might notice, this is a little hard to read. This is a 3, these red 3s. So the number 5, right, it's 3 times the previous Fibonacci number minus the Fibonacci number above that. And that pattern is true anywhere. So like, for example, 377. It's 3 times 144 minus 55. Wow. He happened to notice that. I thought, that's really cool. So if we arrange these Fibonacci numbers not in a single column, what Jairo discovered is that if we use 2 columns, we get a multiplier of 3 right here, and the sign of the number that's 2 above is a minus sign, right? So does that make sense? We've got, the multiplier of 3 and then a minus right next to that. So then, of course, the natural next question is, well, what if we made 3 columns? So Jairo did this, 1, 1, 2, 3, 5, 8. So he's staggering the numbers into 3 different columns. Every third number is in a particular column, and he noticed something again. In this case, each number, like 13, is 4 times the number above it plus the number that's 2 above it. And so it turns out that, again, that is true anywhere you look in this picture. And so if we add another layer to our table, 3 columns, we have a multiplier of 4 with a plus sign on the Fibonacci number that is 2 above it. And you can keep going like this. You can make 4 columns. There'll be a multiplier of 7 with minus signs. Okay? And it just keeps going. 5 columns, 6, 7, 8, 9 columns. The multipliers are here in red, 1, 3, 4, 7, 11, 18, and so on. And the sign of the number that's 2 above alternates. Plus, then minus, then plus, then minus. It's a very interesting pattern. It turns out that these numbers in red, I hope you can read them okay, 1, 3, 4, 7, 11, 18, 29, actually follows another pattern. Those multipliers that we saw in the Fibonacci sequence are actually creating another Fibonacci-like sequence. Start with the number 1 and 3. Add those together, you get 4. 3 and 4 makes 7. 4 and 7 makes 11, and so on. It's just like the Fibonacci relation, but with a different initial condition, essentially. The first 2 numbers are 1 and 3 instead of 1 and 1. It was amazing. I was so excited to see that. And so then we actually, okay, this is where you then state the big theorem. You figure out what is actually going on, is that we can talk about a particular Fibonacci number, let's say f sub n, in terms of earlier Fibonacci numbers. The k that you see in the formula here is the number of columns that you were using. So it could be 1 column, 2 columns, 3 columns, and so on. And this is a beautiful equation. Now, I'll be honest with you, there are lots of well-known relationships among the Fibonacci numbers, but this one is essentially a new one that Jairo had discovered. He didn't really have the whole generic version of the formula when he brought it to me, but we sat down and worked on it together and came up with this one. And it's quite a nice result. Jairo has had the opportunity. He's now a high school teacher in the Anaheim School District. But he did the circuit of going to the local conferences and putting together a poster and presenting his work. You can kind of see right here he's talking about that formula I was just showing you a little bit ago. Very exciting for me to sort of be a part of that. You know, it was mainly Jairo that did all the legwork, but to be able to participate in that mountaintop moment experience that he had was very gratifying. I also got to present this work with, this is Jairo, it's not a great picture, but we went out to the National Council of Teachers of Mathematics conference, which is a national conference. It was held a few years ago in Denver, and Jairo and I gave kind of a joint, we co-presented a nice talk about what he had discovered, which I thought was really neat. So usually it's not the student bringing the project to the mentor. It generally works the other way around. And that leads me to the last of my points about how to create mountaintop moments. Good projects. Good projects, right? So we need good projects. What's a good project? Well, it's going to be hard in undergraduate mathematics to bring a good project to a student. There's some things over the years that I've kind of learned that work well. I think problems that are easy to understand relatively quickly are nice. The students aren't here that long, right? We need to get them moving on something so they have time to discover some math, perhaps, have a chance to take it somewhere to a conference and present it. We have to have time for our students to do those things. There should be easy examples that the students can explore. And a lot of times the projects that we bring evolve or lead to new projects. I think that's also very useful because that way it may not just be one student that gets the benefit of the project, but a whole line of students through the course of an investigation over a number of years. So this idea of good projects and finding new projects works in the mountain world too. It has worked for me. When I first showed up in Colorado to the YMCA and started working there, I said, you know what? I want to climb all of the highest mountains around here. So I found a list. I'm a man of lists, by the way, as you're going to see. These are the 10 tallest mountains in Rocky Mountain National Park. 14,259 feet, Long's Peak is the tallest. And these top 10 peaks are pretty tough to climb. But I made it a goal. And over the years that I was working there, I not only have climbed these mountains, I think I've probably led a Y hike of guests up to the top of every single one of those as well. So it's been quite a fun adventure. But once that was done with, once that project was completed, I figured there's got to be something else I can do. And so I decided to take a map of the entire Rocky Mountain National Park. All of these little triangles are showing you the different mountains, and I said, I want to climb all of them. That's a lot. And I actually have been able to do most of them. There's a couple that I'm still working on. You have to have like ropes and stuff. It's not really my forte. So I'm hoping I can get some help with those. But anyway, I've just about finished that project. Meanwhile, I've moved on to another project called the 14ers. In Colorado, there are 58 mountains that are over 14,000 feet tall. 58 of them. That's a lot, but I made it a goal. I want to climb them all. I'm going to try to climb them all. And it turns out that I have actually been able to finish doing that. I didn't need any ropes for any of them, which was nice. There's actually, this is my, I should take a moment and show you here. In the summer, I spend a lot of my time on this website. Let me see if I can pull up. Is this connected to the internet? There's no internet here?
There is, but you're not.
Okay, you know, that's okay. Let me just skip that. If you go to there's a website called 14ers.com. 14ers.com. It's got all 58 of the peaks listed there. You can read these trip reports of people who've been climbing them recently, what they had to say about it. Kind of get some pictures of the routes, and so you kind of know where to go. It's kind of an interesting thing to look at from time to time. So the 14ers, you can kind of break them down by classes. So we talk about what kind of a class hike you have. Class 1, you're just walking on a trail. Class 2, there's no trail, but you can still just walk on the ground somehow. Class 3 is where you actually have to start using your hands and scrambling a little bit. And then Class 4 is where you actually have to really scramble. Probably use your hands and legs and move in kind of awkward ways with your body to get through the terrain. Fortunately, I never have to do a Class 5 climb on a 14er because none of them are that hard. So it goes all the way up to Class 4. So here's an example, Class 1 trail. You see the trail right there, Mount Elbert. That is the highest mountain in Colorado. So I climbed that in 2011. 2013, I climbed Mount of the Holy Cross, and you can see there's no trail here. It's kind of just a rocky tundra. So you just walk through the terrain, and that's a Class 2 hike. Okay? This is class 3. This is where usually that's my rule of thumb for the helmet. If a hike is class 3 or harder, I put this helmet on. And you can see here I'm kind of going up this pretty steep gully. There's some snow in there and everything, so got to be a little more careful and do some scrambling. But none of these climbs compare to the class 4 climb called Capitol Peak. This is the hardest 14er in Colorado, according to myself. Having done them all, I would say this is the hardest one. And I also think that most people that you talk to who've done them would say the same thing. The reason is not only is this terrain really crazy, you can see you kind of go up the ridge line here. At one point along the ridge, it sort of disintegrates into a knife edge. That's me right there. So yeah, projects that lead to new projects. The 14ers was a great example of that for me. Really quickly, I'm going to tell you an example from the math world. Does fill in the blank have a square root? That may sound like a fairly simple question. You know, do I have a number that when you square it, do I have a number such that there's another number whose square is equal to it? So we could start with something like 25. You probably would all imagine, okay, the square root of that is 5. 5 times 5 is 25. Easy. But then we get to something like 18, and suddenly it gets harder already. Does 18 have a square root? Well, the answer is it kind of depends. It depends on what kind of numbers you're going to allow yourself to work with, right? So if you're going to only work with whole numbers, then you would not have a whole number square root for 18. But if we make the table a little bigger and allow ourselves to use decimals, like real numbers, well, then the square root of 18 is approximately 4.24, right? So you can imagine doing this with any number of different numbers. Here we have an interesting one. Take a negative number. Okay, well, that doesn't have a square root. Unless maybe some of you have seen the complex numbers? The number I, this is this made-up number that such that I squared equals -1. So -1 has a square root, and we call it I. And so the square root of -4 is just 2i, because 2i times 2i would be -4. So this becomes a more complicated question fairly quickly. You can even ask this question in other mathematical contexts besides ordinary numbers. So when I talk about clock arithmetic, I'm referring to a number system where you sort of start with 0, 1, 2, 3, 4, all the way up to 12, and you recycle back to 0 again, right? It's called modular arithmetic. Like if it's 11 o'clock right now, what time will it be 4 hours from now? You probably would, in your head, calculate that that would be 3 o'clock. So 11 plus 4 equals 3 if you're doing clock arithmetic, right? So you can ask yourself, well, do these elements over here have square roots if I use clock arithmetic? And that takes some thought to come up with what the answers would be. But you can play with that question. You can also ask how many square roots are there? And what about cubed roots or fourth roots or fifth roots? Lots of students could get involved in a very simple project based around this problem. It's pretty easy to understand it. You can play with examples readily, and you can come up with some ideas. Look for some patterns and collect some data. More generally, since I'm an algebraist, I don't even necessarily work with numbers that often. I'm working with algebraic structures that are even more abstract than the examples I just showed you. But the same fundamental question, what conditions would it take for an element, for an object, in other words, in one of these very abstract structures? Okay? What would it take for an element to have a kth root, or a square root even, in one of those kind of structures? So we could look at matrices, or permutations of a set. even permutations of a set, partial permutations of a set. I'm not going to go into what all these things mean right here, right now. These are different algebraic structures, and a whole host of different students have been able to explore these different projects over the last quite a number of years, and it's still going on today. I still, as of today, have research students working with me on just different variations of that same fundamental problem. Does fill in the blank have a square root? You take a simple question that is easy to kind of make sense of in a familiar context and try to broaden your scope at which you're playing with that question and see what you can come up with. There's lots of applications to this stuff. It doesn't always come to light right at the time you're doing the research, but number theory and questions about roots are all tied up with factorization of large numbers, which in turn is very related to cryptography, which is very important every time you put your credit card information over the internet. It's being protected through a crypto system that is based on the difficulty of factoring large numbers. So there's lots of great examples of that nature. Finally, I just want to emphasize the journey. With a good project, the journey is more important than the answer, right? It's more important what the student is going through to get to the answer than what that answer actually is. As a quick illustration from the mountain world of that, here's a couple of Cal State students that came with me to try to climb to the top of this point right here. This was a little easier than Capitol Peak, although it doesn't look like it from here. And we were out having a wonderful day, but to get to the top of that point, we had to go through these trees back here. And what you cannot see in the trees is all of the snow sitting on the ground. So there's actually a bunch of snow here. This is snow. It's a little hard to tell. And snow is never flat. It's like up and down. It kind of gets in an undulating pattern that makes it very tiring to walk through. And we just got really tired that day. And we just realized that we didn't think we would have as much fun trying to get to the top of that point as we would if we just enjoy the journey. Enjoy some time to lounge around and be in the outdoors, enjoy the forest, the beautiful scenery. And that's what we did that day. The destination was not the primary thing. In fact, we have a whole list of priorities with our YMCA hikes. And getting to the destination is like number 4 on the list. It's behind everything else. Safety, enjoyment, protection of the environment, those things all come first. Here's an example of a place where the joy is in the journey. How many stars have 1,000 points? The answer to that question really is not what's important here. What's important is the process of playing with the problem and discovering ideas for yourself along that journey. So you might start with just a 5-pointed star, right? Just make a star here. For convenience, I put all of my stars inside of circles with sort of equal spacing around the side of the circles to connect the points, right? And you can ask people, okay, so that's sort of your familiar standard example of a star. What about a star with 6 points or 7 points or 8 points? You can start small and start to get ideas. So, you know, there's a couple of 7-pointed stars. Here we have some 8, 9, and these two are both 9-pointed stars. This is a 10-pointed star. Just by discovering, playing with a piece of paper, drawing these circles, there's a little bit of geometry there that you can enjoy. It turns out, though, that the full solution involves not just geometry. There's also some number theory that comes into it, and combinatorics, which is a fancy word for the theory of how to count things. You're counting how many stars you have, so that's obviously relevant for that purpose. But our solution is going to use these tools, and you can learn a lot of math even without getting to the final answer. It turns out the final answer is 199. I'm not going to draw them all. It's a big problem to do 1,000-pointed stars. I ended up writing a book about problem solving. I love problem solving so much that I put this American Invitational Math Exam, which is where that stars problem came from. This is one of those high school math competitions that our Fullerton Math Circle helps to promote and bring high school students in to work with us. And I put together a book that kind of is a collection of problems from that exam over the last several decades. And I like to share problems from that book all the time that have been used. They have some very interesting problems in that competition. So in conclusion, these are the four things that, at least for me, have helped to create a lot of mountaintop moments for my students here at Cal State Fullerton. And I just want to give you some final takeaways today as I wrap things up here. It's so important, as you guys I'm sure know, to do things that you're passionate about. No need to waste time doing stuff that you don't enjoy. I'm very fortunate, I feel, that I love what I do here at Cal State Fullerton. I don't think of it as work. It's actually what I'm passionate about. Working with students on research, in the classroom, out of the classroom, whatever it may be, do the things that excite you, right? Do things that you find fun and engaging, right? This is what it's all about. This is what I do 9 months of the year. This is what I'm doing, is working with those students. Also, secondly, take journeys that take you beyond your comfort zone, right? 98% of the people that go out to Colorado, where I work in the summer, they never go more than a mile from the road, right? Instead, they pretty much drive up and down the road, and then this is what happens. This is an elk, and I like to call this an elk jam. We don't have quite these kind of problems on our freeways, but we have different types of jams. But yeah, people come and they get so excited to take the pictures of the elk, and so they stop in the middle of the road, and well, you just have to wait for them to take their pictures. The rangers come along and try to get people to move along, but it's not always that easy. I would rather see people doing this. Getting out away from the traffic, right? Away from the roads, into the wilderness to experience nature. Maybe to just challenge themselves to do something a little bit different than they've ever done before. Like taking a snowshoe hike up to the top of a snow-covered mountain. Something like that. And whatever it may be for each person that takes them beyond their comfort zone, I like to recommend people to take those journeys. We've got to get our students out of the classrooms, right? Not just sitting in those desks all the time, right? Rather, let's get them up working at the board, active learning, right? Here's an example. I did some independent study with some students that were planning to go to graduate school and wanted to get a leg up, right? So instead of just, they could have just said, no, I'm just going to just take easy classes or whatever. They came to me and said, we want to learn more advanced material. So we set up a weekly meeting to go through some abstract algebra kind of at the graduate level and just give them some exposure to that topic so that they'd be more prepared for their graduate school work, right? Again, just taking a Saturday and instead of just sitting around, go to a conference and hear what other people are doing and share the work that you're doing, right? This is what I tell my students all the time. Doing research, taking students to conferences, kind of back to what I was saying towards the beginning. This was out of my comfort zone. The Southern California Conference for Undergraduate Research, there were more than 1,000 people there. And I think it'll be a little while before I direct another one of these. Just getting the food worked out was enough of a challenge. So directing a conference for me was an example of, for myself, something that I hadn't done before. I said, let's try something different. Let's do something of a more challenging nature there. So taking journeys beyond your comfort zone. And there's always another mountain to climb. You accomplish one thing, there will always be something else waiting. Or it could be not just one mountain, but a whole list of mountains. I talked about the top mountains in Rocky Mountain National Park. I talked about Colorado's 14ers. What's next? Well, there's California's 14ers. There's 15 of those. There's Colorado's Centennial Peaks. I'm working on those. Those are the 100 highest mountains in Colorado. There's even a Southern California 6-pack of peaks. You can go online, Google it, and you'll see that you could those are not so hard to climb. You can just do them locally. But for me, what I've really gotten attached to lately is something called state high pointing. So we have 50 states. Every one of them has a highest point somewhere. There's the map. The star shows where the highest points are. Mount Whitney in California is right there on the dot there. And there's 50 little dots, and I've decided that I want to try to climb some of these. And I had started, there's actually a High Pointers Foundation. You can go online and look this up. It's a nonprofit organization to try to protect and preserve these beautiful places. And I started with California back in 2004, and then I went to the highest point of Minnesota, then I went to the highest point of Colorado, Arkansas, Hawaii, Texas, Tennessee, North Carolina, New Mexico, Arizona, South Dakota, North Dakota, Nebraska. That was a tough one.
Yeah. I didn't see.
Yeah, there's pretty much in the cornfield right there. Just pull the car up and step out. So I decided after I did Nebraska, I was ready to go do Oregon. Here I am with my ice axe and crampons, and this is the top of Mount Hood. That's probably the most technical one that I've done so far. I did that last summer. That's pretty tough. Maine was a lot of fun. It's the northern terminus of the Appalachian Trail. Nevada, Missouri, Iowa, that was another tough one. Actually, that was really tough. I did it on New Year's this year, and it was -5 degrees when I stepped out there. I could barely take a picture before I had to get back in the car. Mississippi, a few weeks ago I did Idaho, and guess where I was 2 days ago?
What?
I was right there. 48 hours ago, I was in Utah. I flew out Saturday morning. I climbed 30 miles. This is one of the hardest state high points. 30 miles to 13,528 feet. Kings Peak in Utah is my most recent state high point. So I, of course, in my office have a map showing where I've been and how I'm coming with this this mountaintop journey. So I just filled in Utah.
Louisiana is not going to be too hard, but the food's better.
The food's better, I'm sure it is. Yeah, I've got to get down to Louisiana still. I've got most of the eastern U.S. still to go. But it all comes down to these peaks over here in the west. And we're not even going to talk about Alaska. My mom won't even talk to me about that one. That's Denali. But anyway, this has been kind of a fun project. It's taken me to see new places, new things. There's always another mountain to climb. And finally, anyone with proper motivation and support can find success both inside and outside of the classroom. Anybody can do it. I remember Jairo. I go back to him again. The guy who I met, here he is, Jairo. My very first year at Cal State Fullerton, this is me. And this is Jairo. And, you know, he was coming from pretty humble beginnings. And, you know, I saw something in him. I was really very proud of him. I got to have him for several classes. And then, yeah, to get to see him receiving his master's degree a couple of years ago here at Cal State Fullerton was really a heartwarming experience for me as well. There's a similar analogy in the mountains I want to leave you with. When I first worked at the YMCA of the Rockies, I would look out at this view. And I said, you know, I want to climb these two mountains. I just want to go up there. I look at them every day. I would like to stand on top of those mountains. And so I did it. I climbed those mountains. I got really into shape and worked my way up, and I did it. And I started posting some pictures of what I was doing. And you know who got interested in my pictures? It was my parents. They started looking at my pictures. They were 60s. They were in their 60s. They started looking at my pictures and said, you know what? I'd really like to do that too. And they weren't in the best of shape at the time, but once they realized that to get to the top of these mountains, they're going to have to work pretty hard, they started swimming and walking in the off season throughout the year. They got themselves into shape, and I was so excited that in 2009, this is my mom, she got to the top of that. These are this mountain and the one she's standing on are those two mountains from the previous picture. And this was an epic adventure for her. We camped out. It was a 2-day, 20-mile trip over 2 days, and a very exciting moment. Not only that, I also addicted them to the 14ers bug. So in 2011, my mom said, I want to go climb a 14er now in Colorado. So we went up Quandary Peak. Here it is. There's my dad, my mom, and myself celebrating the top of one of our mountaintop moments, if you will, together as a family. And so I really should dedicate pretty much everything that I've been talking to you guys about today to my mom and dad. They've been so inspiring to me and helped me to pursue my passions both academically and in the mountain world. And so for that, I am always grateful to these two, and I'm glad that I've been able to share so many adventures with them. And thank you all for allowing me to share some of my adventures with you this morning.